Okay, so we are going to continue with section 2.1, and we are going to be a little bit more descriptive about the domain of a function. And the domain of the function we talked about before is a list of all the x values that we see in a set. And keeping with that thought, the domain is a set of all possible x values. But when we're looking at a function, like we see right here, we can think, okay, I can put anything in that function for x. All right, so if I put, and I just want to think about some values I put in for x, if I put in x equals 1, I can compute 1 squared plus 5x equals 1 squared plus 5 times 1 equals 6. If I put in negative 3, I have negative 3 squared is 9, plus 5 times negative 3 is negative 15, and that would be negative 6. So what I'm getting at here is any value I put in for x, I'm going to get out one y value. And it doesn't matter what the x value is. I can put in any number I want. All right, so in this case, because I can put in any number for x, we're going to say that the domain is all real numbers. And that's what that little funny r stands for, all real numbers. But there are times when some values for x will not work in a function. And we call those restrictions. And there's a couple of key things that we want to look for to find restrictions. And in example B, we have a rational function. So we have a top number or a top function and then a bottom function, and they're being divided. And if, for example, in this function, the denominator ended up equaling 0, okay, so if we have a denominator equals 0, so let's say I put in 2. I would have 2 squared is 4, and 4 minus 4 is 0. And we know that we cannot divide by 0. That's undefined. So in this case, I can put in any number I want for x, but I know x cannot equal 2 because I would be dividing by 0. And that's also the case for negative 2. If I plug in negative 2, I still get 4. Minus 4 is 0. So really what we want to do here to find those restrictions is we want to set the denominator equal to 0. So if I say x squared minus 4 equals 0, this sentence will tell me any values on the denominator that would be 0. Okay, and I can solve this. I can either factor this, or I can just add 4 to both sides, and then square root both sides, and x would equal plus and minus 2. So these would be the restrictions on this function. So in my domain, I would say for all values of x, and that little line says except for x equals plus and minus 2. To say this again, the domain is all values of x except for the values x is plus or minus 2. All right, so if we're looking for restrictions, we want to find numbers where the denominator is 0. And if we look at example C, we have numbers inside of a square root sign. And we know that the numbers inside the square root sign have to be positive numbers or 0. They cannot be negative. So to find out if we have any negative values, I'm going to take this function that's inside the root sign, which is 4 minus 3t, And I'm going to say that those values have to be greater than or equal to 0. If I solve this inequality, I'm going to subtract 4 on both sides. So negative 3t has to be greater than or equal to negative 4. And if I divide by negative 3, I'm going to say t, and remember, if I'm dividing by a negative, I have to turn my sign around, and that would equal 2 negatives make a positive, 4/3. So in my domain here, I can only include numbers that are less than or equal to 4/3. To show that, I'm going to say that my domain can equal any x such that, or in this case it would be t, sorry, such that the values have to be less than or equal to 4/3. Okay, so these are the only numbers that will work in this function. So these are other restrictions that we can look for, where the numbers will give us a negative number inside the square root sign. Okay, so those are the two big things that we're going to look for right now in terms of restrictions on our domain. In this last section down here, we're going to see two functions, and we want to perform some operations on those functions. So this first one says, I want to take the f and the g function and add them together. So if I rewrite this sentence as 1 over x plus 2, and I'm adding that to the g function, which is x over x minus 1. Now we need to remember some of our rules about adding and over here subtracting rational numbers. We know that when we have a fraction, we need to have a common denominator. In that denominator, we need the factors of x plus 2 and x minus 1. And then we need to rewrite those fractions with those numerators that would make equal fractions. So if I multiplied this fraction here by x minus 1 to get my common denominator, I also have to multiply the top by x minus 1. And if I multiplied the denominator, x minus 1, by x plus 2 to get my common denominator, I also need to multiply the numerator by x plus 2. So really what I did on each of these is I multiplied the top and the bottom by factors to get a common denominator. Now I'm going to rewrite my numerator. Excuse me. So if I multiply 1 times, let's switch here, 1 times x minus 1, and I'm going to add that to x times x plus 2. Now I'm going to get rid of my parentheses on the top, and I'm going to simplify. So if I distribute here, I have 1 times x times 1 times minus 1, that's x minus 1. My denominator will stay the same, x plus 2 and x minus 1. Over here, I'm multiplying x by x plus 2, so I get positive or plus x squared and plus 2x. And if I notice, I have a common like terms here, so I can add those together. So if I simplify that, I'm going to have, and I'm going to put this in order of descending exponents. So I have x squared, and I have a positive x plus a 2x is plus 3x. and then a minus 1. And my denominator, I'm going to leave as factors. I don't need to multiply that out. Okay. The next one is very similar. This time we're subtracting the functions, so I'm going to start in the same way, 1 over x plus 2. This time I'm subtracting x over x minus 1. Still need a common denominator. Adding and subtracting requires a common denominator. And in the same fashion, I'm going to multiply the top and bottom here by the number that's missing, by the factor that's missing in my common denominator. So I'm going to have an x minus 1 right here over x minus 1. So this is like multiplying it by 1. Then this side I'm going to multiply by x plus 2 over x plus 2. And if I distribute, 1 times x minus 1 is x minus 1. And then here, when I distribute, make sure that you're distributing with the negative. So this is negative x times x is minus x squared, and negative x times 2 is minus 2x. Simplifying that, my common denominator keeps those factors, and my numerator takes the highest exponent. Now this is negative x squared. Now for my x's, I can combine like terms. I have positive x plus negative 2x, or x minus 2x is negative 1x, and then a minus 1. Part C asks us to multiply those functions together. Now this time I don't need a common denominator. Really what I need to do is just multiply my numerators and multiply my denominators. First I would check to see, is there anything that I can cancel before I multiply? And in this case there is not. So I have 1 times x is x, and the denominator would be x plus 2 times x minus 1. And in part D, last but not least, we're dividing those functions. So if I have 1 over x plus 2, let's do division first, divided by x over x minus 1. I know that division means to multiply by the reciprocal. First fraction stays the same, and I'm going to multiply by the reciprocal of the second fraction, so x goes on bottom, x minus 1 on top. And if I simplify, 1 times x minus 1 is x minus 1. And in my denominator, I have an x and an x plus 2. If you feel the need to multiply that out, that's fine. I prefer to leave my denominators as factors. Either way is acceptable. And that will be all for section 2.1.